Now we're going to go over the quiz that was on page 14 in your supplemental materials and how we go about calculating these. Question number 1. You invest $5,000 in account A for 10 years and earn a 10% rate of return. You invest $3,000 in account B for 10 years at 8%. How much do you have in total? All right, so we don't need to necessarily draw these boxes. Hopefully we've got that down a little bit. So we're going to go $5,000 times future value of $1. K equals 10, N equals 10. And we also then invested $3,000 each year, or $3,000 for 10 years. That's future value of $1. K equals 8. N equals 10. These aren't annuities, because if these were annuities, it would have read, you invest $5,000 in account A each year, or $5,000 in account B every year. Those are several payments, and so it'd be an annuity. This is not several payments. It's for 10 years each, so it's future value of $1. We then look up the factor for both of these. In the first one, we get 2.5937, and the second one is factor 2.1589. Since we're investing and going into the future, if we earn a higher rate of return, the factor is going to be higher. And so my 10% rate of return certainly needs to be higher than the factor for an 8% rate of return. We're then going to multiply 5,000 times my factor, 3,000 times my factor, and get 12,969 and 6,476 for a total value of 19,445. And that's the answer to question 1. Question 2 on the quiz. You invest $25,000 for 10 years at 8%. You open a second account and invest $3,000 each year for 10 years at 10%. How much do you have in total? All right, so we invest $25,000 for 10 years. That's a lump sum. So we're looking at $25,000 times future value of $1. And we have here it's 10 years at 8%. So K equals 8 and N equals 10. The second part of the question, in our second account, you invest $3,000 each year. So each year is several payments. So this is going to be an annuity. So I go $3,000 times future value of an annuity, K equals 10, N equals 10. We look up the factors for each of these. And so the first one is 2.1589. And the second one factors 15.937. 25,000 times 2.1589 equals 53,973. And $3,000 times 15.937 equals 47,811. We add those up, we get 101,784. Question 3. You're offered $100,000 in 10 years. using a discount rate of 8%, what is it worth today? And B, using a discount rate of 10%, what is it worth today? So the only thing here that's changing in this question is K. So I'm offered $100,000 in 10 years. I want to know what it's worth today. It's one payment coming to me in 10 years. So we're going to be coming back present value of $1. So present value of $1, K equals 8, N equals 10, and $100,000 present value of $1, K equals 10, N equals 10. Now, when we're discounting and coming back in time, the bigger the number for discounting, the smaller the number is going to be. So it's kind of like walking in, like we talked about before. You walk into a store, you want to buy some shoes. You would rather see a 10% discount than an 8% discount. If I'm discounting at 8%, pretty good deal. Better deal if I got a 10% discount. This number is going to be lower. If it's not lower, we made an error. So I look up my factors. Present value of $1, K equals 8, N equals 10. That is 0.4632. And at present value of $1, K equals 10, N equals 10. That factor is 0.3855. We multiply that across. We get 46,320 for the present value under an 8% scenario. And under 10%, we get a value of 38,550. Question 4. What is the value of an annuity that will pay you $5,000 each year for 30 years at a discount rate of 6%? What is the value of the annuity if it's a 12% discount rate? Okay, so we know we're getting an annuity, which means several payments. We're going to get $5,000 each year for 30 years. We want to know what its value is today. So we're going to take $5,000 times present value of an annuity, K equals 6, N equals 30, and $5,000 times present value of an annuity, K equals 12, N equals 30. We talked about before, we're coming back present value, and so we're discounting. So one thing I know for sure, the higher the discount rate, the smaller the number. So before I even do my factors, this one needs to be lower. If this answer isn't lower, we made some mistake. So I look up my factor, present value of an annuity, K equals 6, N equals 30. Gives me 13.7648. And present value of an annuity, K equals 12, N equals 30. Gives us 8.0552. We multiply our factor times our 5,000. We get a value of 68,824. And the bottom one, 5,000 times 8.0552, gets us a value of 40,276.